Hello everyone, welcome to the channel. So today's video is all about the chapter named Number Play of Class 8 Ganita Prakash according to the new textbook. So this is a one-shot video where I'll be completing the whole chapter, all the concepts that are there in this chapter. So let's get started. First one is sum of consecutive numbers. Can every number be written as a consecutive number? So firstly, what are consecutive numbers? Consecutive numbers means one, 2, 3, 4. Basically, numbers one after the other. So now, can every number be written as a consecutive number? Let us see. So if I'm adding two consecutive numbers, 1 plus 2, 3, then 2 plus 3, 5, 3 plus 4, 7, 4 plus 5, 9, and so on. So when I'm doing sum of two consecutive numbers, I am getting odd numbers. See, the result is always odd. So when I add two consecutive numbers, I get odd numbers. So let us see what happens when I add three consecutive numbers. 6, then 2 plus 3 plus 4 is 9. 3 plus 4 plus 5 is 12. 4 plus 5 plus 6 is 15 and so on. So when I'm doing three consecutive numbers, what are the numbers that I see? These numbers are the multiples of 3. The result is multiples of 3. Now, similarly, let us take 5 consecutive numbers. 1 plus 2 plus 3 plus 4 plus 5. The result is 15. Then 2 plus 3 plus 4 plus 5 plus 6. It is 20. 3 plus 4 plus 5 plus 6 plus 7 is 25. So what are these numbers? So when I take 5 consecutive numbers, the result is multiples of 5. But can we write every number as a consecutive number? No, there must be some rule, isn't it, to identify what kind of numbers cannot be written. So let us see the rules. Rule 1 is when you add two consecutive numbers, you end up having odd numbers. We have seen. Rule 2 is when you add three consecutive numbers, you get multiples of 3. When you add 5 consecutive numbers, you get multiples of 5. Now, there are some special kind of numbers 2, 4, 8, 16, 32, 64, and so on. What are these numbers? These are powers of 2. What do you mean by powers of 2? 2 power 1, 2 square is 4, 2 cube is 8, 2 power 4 is 16, 2 power 5, 32, and so on. So these are some exceptional numbers which cannot be written as some of the consecutive numbers. So this is very important that yes, powers of 2 cannot be written as some of the consecutive numbers. Next up, we have parity. What is parity? Parity is nothing but if the number is even or odd. So if I take 79, everyone knows this is an odd number. Yes. If I take 2a, now a is a variable as in it can take any values. So 2 into any number, if you think 2 into 3, 6, 2 into 5, 10, 2 into 7, 14, you end up having always an even number. So let us see how do we identify the parity without calculating. So let us see how do we add and subtract and what is the parity coming out. So if I add two even numbers, the result is always even. Let's see 2 plus 4, 6. 2 is even, 4 is even, the result is even. If I add two odd numbers, the result is again even. 3 plus 5, it is 8. See, 3 and 5 are odd numbers, but the result is even. But if I have one even and one odd, the result is always odd. 2 is even, plus 3 is odd. See, I get an odd number. So what do we understand from this? We understand that same numbers, same parity is always even. Same parity as in either both the numbers are even or both the numbers are odd. The parity is always even. But different parity as in one is even, one is odd. The result is always odd. This is very important when we do add or subtract. Now it is same. See, even if we add or if we subtract, the values changes, but the parity doesn't change. When in addition and subtraction, the parity ends up the same thing. Same numbers when you add or subtract, the result is even. Different parity, that means one number addition, one number even, one number odd, the result is always odd. Now, what about when we multiply? Let us see. So if I multiply an even number into an even number, I end up having even number. See, 2 into 4, 8. 2 into 6, 12. If I multiply even number and odd number, still the result is even. 2 into 3, 6. 2 into 5, 10. But if I multiply two odd numbers, I always end up having odd. 3 into 5, 15. 7 into 9, 63. So, what do we understand from here? That even into anything, whether it is odd or even anything, it is always an even number. But odd into odd always gives you an odd parity. This is about multiplication. So not necessary, I don't want you to by heart. I don't want you to by heart. It is just that if you have, you can just take small numbers, 1 into 2, 2 into 3, small numbers and find out then and there. But without calculating, you need to know this. Same parity, even. Different parity, odd. Even into anything gives you even. Odd into odd gives you odd. Next, four consecutive numbers plus with plus or minus. So what happens when I take four consecutive numbers? What is the parity? So let us take four consecutive numbers 10, 11, 12 and 13. So I see this is even, odd. So when you take four consecutive numbers, definitely two numbers will be even and two numbers will be odd. So when I add even and odd, different means always odd. Again, when I'm adding even and odd, different parity odd. Now when I'm adding the results, same parity, it is always even. So when I add or subtract four consecutive numbers, the result is always an even number. Now this is important. Sign changes the value. See, when you add something, subtract something, sign definitely gives you a different value. But they don't change the parity. The end result will always be even. The parity doesn't change even if you change the signs. Next, without calculating, tell whether the answer is even or odd. So this is even. Let us do quickly. This is, sorry, odd plus odd. Same parity, even. Even. Again, same parity, even. Now, 4, 4 is an even number. What did we see? Even multiplied by anything always gives you an even number. This is even, this is odd. Different parity, odd. Odd and even. Different parity, odd. Now, odd into odd. Odd into odd is always an odd number. Odd, odd. Different parity, same parity, even. Now, 5 and 3 whole cube. It is odd because 3 cube. At the end, you're going to get 7, which is odd. Now, let us see these algebraic expressions. 2a plus 2b. So, I can write it as 2 into a plus b. Now 2 multiplied, even number multiplied by anything gives you an even answer. Now 3G. Now here it is interesting. E3 is odd. Now G can be even or odd. If it is even, then the result is odd. But if it is odd, the result is even. So it can be even or odd. Same with 5H. It can be an odd number. It can be an even number depending upon what you're taking H as. So for these cases, you cannot determine. Now this is 2 into 2m plus n, isn't it? So even number multiplied by anything is always even. Similarly, 2 into u minus 2v. Even number multiplied by anything is always even. 13k minus 5k is 8k. Now 8 is an even number. Even multiplied by anything is even. 6m minus 3n. Now, if I take 3 common, you get 2m minus n. So, 3 is an odd number, isn't it? This is odd, but the bracket part, what is the bracket part? Bracket part can be anything. So, you cannot determine. Now, x square. Whenever you have squares, you cannot determine because it depends upon what is the value of x. If x is even, the result is even. If x is odd, the result is odd. So you cannot determine this as well. Cannot determine. Last, 4k into 3j. 4 into 3 is 12. So even number multiplied by anything is always even. So if you understand the parity, you can answer without calculating. Next, moving on, multiples. What are multiples? Let us take 7m. Now 7m, multiples of 7. What are the multiples of 7? 7, 14, 21, 28, 35, and so on. So how do I get multiples? 7 multiplied by any number. The result that you get are the multiples. So 7 into 1, 7. 7 into 2, 14. 7 into 3, 21. 7 into 4, 28. 7 into 5, 35. So these are all multiples of 7. Also, it is given 0 is a multiple of every number. Yes, it is. Look, 2 into 0, 0. 3 into 0, 0. 4 into 0, 0. So 0 is a multiple of every number. Now, pairs to make fours. This is very important and it is very, complicatedly given in the textbook. So let us first understand easily. I'm sure if you see this video, if you look at this slide, I'm sure you will understand. And then after this, you can go through the textbook. You will understand in a better way. Even numbers are classified into two types. One is multiples of 4. Multiples of 4 may 4, 8, 12, 16. These are all even. And the other set is not multiples of 4. Not multiples of 4 may you have 2, 6, 10, 14. These are even but not multiples of 4. So let us crack these three types. So first one is multiple of 4. Let us take multiple of 4 as 4a plus multiple of 4. Another multiple of 4 as 4b. So the result is also multiple of 4. How? I can take up 4 common. So 4 into a plus b. So this is definitely multiple of 4. Yes, because 4 into any number gives a multiple. Next, second one, not a multiple of 4. I can take 4 is a multiple. So if I add plus 2, it becomes a not a multiple. Again, addition, not a multiple of 4. I can take 4b plus 2. It's not a multiple. So what do I get? 4a plus 4b plus 2 plus 2 is 4. So 4 into a plus b plus 1. So 4 multiplied by anything is a multiple. The result will always be a multiple. Lastly, multiple of 4, let's take 4a. Not multiple of 4, let us take 4a plus 2 because it's not a multiple. 4b plus 2. So what do I get? I can take 4 common a plus b, but I still have plus 2 remaining. This is a multiple, but when I add 2 to the multiple, it becomes not a multiple. So what did we see? When I add two multiples of 4, 4 plus 8, the result is also multiple. When I add two non-multiples, 2 plus 10, the result is still a multiple of 4. But when I add a multiple of 4 with a not multiple, the result is not a multiple of 4. So this is given in a complicated way in your textbook. So try and understand here and then go through the textbook. It will be easier. Now, next up we have some statements which are very, very complicated in the textbook. So here, these are some 7 to 8 statements which we need to identify if it is always true, if it is sometimes true, as in sometimes true, sometimes false, or it is never true. So we will understand one by one statements because these are very, very important. In exam, you might get for one mark question. So if you understand this, it will be easier for you to answer any kind. If 8 exactly divides two numbers, so I can take the two numbers as 8a and 8b because see 8 exactly divides means remainder should be 0, no remainder. If I divide this by 8, see I get remainder 0. So I can take 8a and 8b. Then it must divide their sum. Let us see. When I add them, is it dividing 8 into a plus b by 8? Oh, yes, it is exactly dividing. So this is always true. This is always true. So now, see, directly if I read this statement in yellow, you will not understand. So which is why I've given you these statements. First, if we take numbers, take examples and do it. Then if I read the statement, you will understand in a better way. Let's see what is there. If A divides M, A is nothing but A divides M and A divides N. You can see 8 is dividing 8a and 8b. Then it also divides m plus n or m minus n. That's what we have seen. In other words, if m and n are multiples of a, so it is very clear that these are multiples of a, 8 is multiple, 8b is multiple of a, then the sum will also be multiple. Next one. If a number is divisible by 8, let us take 18. Then 8 also divides any two numbers. Let us take the two numbers as P and Q that add up to a number. Hmm? What is this? 8 also divides any two numbers that add up to a number. So when I add up, you get the number. So what is this? So let me take numbers and see, okay? A number is divisible by 8. Let us take the number to be 72. It's divisible by 8. So what is it saying? Then it divides into two numbers. So when I add these two numbers, I end up having 72. But what is it saying? That these two numbers are exactly divisible by 8. So I can take 24 plus 48. 24 plus 48 is 72. This is also multiple of 8. This is also multiple of 8. It is true. But okay, what if I write 72 as 50 plus 22? Is this a multiple of 8? No. Is this a multiple of 8? No. So this statement is sometimes true. It is not true always. We saw that when you take a number that is divisible by 8, it can be divided into two parts, which when added gives you that number. Now, these two numbers might or might not be divisible of 8. So that is why it is true or false. Sometimes true, sometimes false. So the answer is sometimes. Okay. Next one. If a number is divisible by 7, all right, 7m, then all the multiples of that number, what are the multiples of 7? 14, 21, 28, 35. All the numbers of that number will be divisible by 7. What do you think? Yes. Is it true? Yes, it is true. Now, 14 is divisible by 7. Yes, because 14 by 7, if I do, 14 definitely has 7 into 2. It will be cancelled. 28, if I take 28, can be written as 7 into 4. Is it divisible by 7? Yes, it is. 35 is 7 into 5. Is it divisible by 7? Yes, it is. So all these multiples has 7 in it. So that 7 and the denominator 7 can be cancelled. So this statement is always true. What is this statement? In general, if A is divisible by K, then all the multiples of A are divisible by K. Yes, if all the multiples are divisible, that means 14, 21, 28, 35 are also divisible by 7. I hope this is clear. Yes. So basically, if I take 7m is there, now multiples of 7m will be 7m into 1, into 2, into 3, into 4, into I, anything. So whatever the result you get, 7m into I. Now this is also divisible by 7. Yes. So if a number is divisible, then its multiples will also be divisible. Next. If a number is divisible by 12, so let us take the number to be 12, then the number is also divisible by all the factors. What are the factors of 12? 1, 2, 3, 4, 6, and 12. These are the factors. Then all these factors will be divisible by 12. Is it? Let us see. Is 2 divisible by 12? Yes, it is. So this is 12. Yes, it is. Now 12 can be written as 12, even if I multiply 12 into 6. So is this divisible by 2? Yes, it is. If I multiply 12 sevens and then divide by its factor 3. So all these factors has 12 in its table. All these factors has 12 in its table. See, 12 into any number. Let's take 9. Is it divisible by a factor? Yes, it is. 4 ones are 4 threes are. If I take 12 into any number. Is it divisible by 6? Yes, it is divisible. So if a number is divisible by 12, be any number, so that number will definitely be divisible by all the factors because all these factors has 12 in its table. So it can be easily cancelled with 12. So what is the statement? If A is divisible by K, then A is divisible by all the factors of K. Yes, because all the factors will have 12 in its table. So these statements try to take the values. I've taken the values 12, sometimes 7, sometimes 8. So then it is easier to understand. I'm very sure now it is confusing that, oh, the statements are really confusing. It is. These kind of statements are to be confused, but the more and more you practice, the more and more you go through the video, the more and more you see the statements, it will be easier for you. Next up, fifth statement. If a number is divisible by 7, let us take 7m, then it is also divisible by any multiple of 7. What are the multiple of 7? 14, 21, 28, 35. Is it true? What do you think? Is it true? So if a number is divisible by 7, okay, this is divisible by 7. Let me take 7 into 2. Is this divisible by 14? Yes, it is. Again, 7 into 2. Is this divisible by 21? 14 by 21. Is it divisible? No. 7 into 3 if I take and dividing by its multiple. 21 by 28? No. So it is not necessary if a number is divisible by 7, which means, you know, 7 into 2, 7 into 3, 7 into 4, whatever. Then then it is also divisible by any multiple of 7. It is not true. Sometimes it is true, but most of the times it is false. So the answer is sometimes. It is not true always. Understood? Next one. Now these two statements I want you to listen very, very carefully. If a number is divisible by both 9 and 4, okay, it must be divisible by 36. Okay, both 9 and 4 divisible. Let me take the LCM. How do we take the LCM? 3 threes are 4. Sorry, sorry. 3 ones are 4. 2 ones are 2 twos are. So what is the LCM? 36. Yes. So if a number is divisible by 6, it must be divisible by 36. 36 is the LCM and 9 into 4 is also 36. Okay. The next statement if I see. If a number is divisible by 6 and 4. 6 and 4. What is the LCM? 2 threes are 2 twos are. LCM is 2 twos are 4, 4 threes are 12. Okay. It must be divisible by 24. Is it true? What do you think? Let us take some example. If a number is divisible by 6 and 4. Okay. Let us take 12. Is 12 divisible by both 6 and 4? Yes, it is. It is divisible. But is it divisible by 24? 12 by 24, is it divisible by 24? No, it is not divisible. It is not divisible. So, what is the statement here? If A is divisible by K and A is divisible by M as well. So, a number you're taking divisible by two numbers. Then A will be divisible by the LCM. It will be divisible by the LCM and not by the product. So 6 into 4, here it is 24. But if we see the previous slide, it was 9 and 4 divisible by 36. And 9 and 4 LCM is also 36. That is why that statement was true. So when a number is divisible by two other numbers, then this number will be divisible by the LCM of these numbers, not the product. I hope this is clear. This number will be divisible by the LCM of these two and not the product of these two. Okay. So this is the statement about the two numbers. Next, last one. When you add an odd number with an even number, okay, when you add an odd number with an even number, we get multiple of 6. Is it true? Let us take any random. Odd number is 3, even number is 6. We get 9. Is 9 a multiple of 6? No, it is false. It is never true. It is never true. All right. Okay, because if we see multiple of 6, multiples of 6, if I say 6, 12, 18, multiples of 6 are all even numbers, right? Multiples of 6 are all even numbers. But when I do odd plus even, different parity is always obtaining odd number. But multiples of 6 are even, so this is never true. It is always false. So these 8 statements, I know it is confusing, but I want you to go through the video again and again, refer to it 3 to 4 times, and I'm sure these statements will be easier because these are very, very important. You will be getting for one mark each in the question. All right. Now let us see some question. Find a number that has a remainder of 3 when divided by 5. Okay. So when divided by 5. Now 5n, when I divide by 5, the remainder is 0 because it is exactly divisible. But remainder of 3, so I can take 5m plus 3 is such number, isn't it? I can take that 5m plus 3 is a number which leaves 3 as the remainder. This is exactly divisible by 5. I need 3 as the remainder, so I added plus 3. Now, to write such numbers, I can assume m to be 1, 2, 3, and so on. So, if m is 1, 5 into 1 plus 3, 8. If m is 2, 5 into 2 plus 3, 13. If m is 3, 5 into 3 plus 3, 15 plus 3, 18, and so on. These are such numbers which when you divide by 5, you will have 3 as the remainder. So if you identify in algebraic form, it will be easier to write the numbers. Next, suppose P is the greatest of 5 consecutive numbers. You have 5 consecutive numbers, 1, 2, 3, 4, 5. P is the greatest. So P will be here because if I have 5 consecutive numbers, 1, 2, 3, 4, 5, these are my 5 consecutive numbers. Greatest is at the end. Determine other four numbers in terms of P. Now, what is my previous number? It is 1 less than 5. So 1 less than P, P minus 1. Again, what is my previous number then 4? 1 less than the next number. So P minus 2. Similarly, P minus 3, P minus 4. So these are the remaining four numbers. Next, the sum of four consecutive number is 34. What are these numbers? So let us take consecutive numbers. If I take one consecutive number as n, the other will be n plus 1, n plus 2, n plus 3. So sum of these is given as 34. Let us find n. 4n plus 3 plus 2, 5 plus 1, 6 is 34. 4n equal to 28, n equal to 7. So n is 7, 8, 9, 10. These are the four numbers which when added gives you 34. All right. Next is the divisibility test. Very important. So here we have some divisibility numbers. Let us see the divisibility test. This is the last topic. So firstly, last digit. In which divisibility rule do we see the last digit? 2, 5, and 10. So for divisibility rule of 2, the last digit should be even. For divisibility rule of 5, the last digit should be 0 or 5. And for the divisibility rule of 10, the last digit should be 0. All right. Now, last two digit. In which divisibility rule do we see the last two digit? Rule of 4. So for example, I have so big number 5, 2, 1, 6, 2, 9, 8, 0. All right. Such big number. I only need to focus on my last two digit. Is 80 divisible by 4? Yes, it is. So the number is divisible by 4. Next, last three digit. When do we need to check last three digit? In divisibility rule of 8. So if I have a big number 3, 1, 2, 8, 1, 3, 5, 1, 2. I'm only going to check last three digit. Is 512 divisible by 8? Yes, it is. So the number is divisible. Now, sum of the digits. 3 and 9. So here we need to add all the digits. Let us take 7 to 7 to 1 2. All right. So 7 plus 2, 9. 9 plus 1, 10. 10 plus 2, 12. Is 12 divisible by 3? Yes, it is. So the number is divisible by 3 and not 9. The end number should be divisible by 3. Only then the number is divisible by 3. Or I can say the end number, the sum should be divisible by 9. Only then the number is divisible by 9. So what all did we see? We have seen 2, 3, 4, 5, 8, 9, 10. Now, divisibility rule of 6 is nothing but for 6, 6 says that if it is divisible by 2 and 3, then the number is divisible by 6. So only thing is you need to check that if the number is divisible by 2 and 3, then the number is divisible by 6. All right. Now next is the 11, which is sometimes complicated to some students. So let us see 11. All right, let us take a number 1078. So in divisibility rule of 11, I need to segregate. These are my odd places and these are my even places. Even places are underlined, odd places are circled. So I'm talking about even places, not even numbers, even places. So odd places sum 1 plus 7, 8. Even places sum 0 plus 8, 8. Once I find the sum of odd place and even place, I'm going to subtract. What am I getting when I subtract? 0. So upon subtracting, if you get 0 or multiple of 11, then the number is divisible by 11. Then the number is divisible by 11. All right. So here is the complete divisibility rules where you can see all divisibility rules of each and everything and you can understand. So one question, let us see this question. Check whether 7920 is divisible by each of the following numbers. So let us check one by one. Is it divisible by 2? Yes. What is the rule of 2? Last digit should be even. It is divisible. 7920. Is it divisible by 3? What is the rule? What is the sums? 9 plus 2, 11. 11 plus 7, 18. Is 18 divisible by 3? Yes, it is divisible. Now, divisibility rule of 4, last two digits we need to see. Is 20 divisible by 4? Yes, it is. Now, divisibility rule of 5, last digit should be 0 or 5. Yes, it is there, so divisible. Now, 7920, is this divisible by 6? Yes, because 6 is what? It should be divisible by both 2 and 3, and hence it is divisible. Now 7920, is it divisible by 8? Last three digit. So is 920 divisible by 8? 8 ones are 8, 8 ones are 8 ones are 8, 8 fives are 40. Yes, it is divisible by 8. 7920, is it divisible by 9? Sum we just found 18. Is 18 divisible by 9? Yes, it is. 7920. The last digit is 0, so it is also divisible by 10. 7920. Now, divisibility rule for 11. I circled odd places, underlined even places. So, odd places sum 7 plus 2, which is 9. Even places sum 9 plus 0, which is 9. So if I'm subtracting, I get 0. So if the result is 0 or multiple of 11, then the number is multiple of 11. So this is divisible by all the numbers. All right, one last topic for the chapter, digits in disguise. So here you have UT into 3 gives us PUT. Yes, so you need to use this hit and trial method. Okay, so now if I see this, this and this number should be same, TT should be same. So how can it be same? So if this is 0, 3 into 0, here also it will be 0. Or if this is 5, 3 into 5, 15. This will also be 5. Yes? So let us take this as 0 or 5. We can do it with both. Let us take this as 0 first. Okay? So if it is 0, 3 into 0, 0. Now, 3 into what number gives you P? You think 3 into what number gives you a two-digit number where this is 3, 3 threes are 3, 4s are 12. 3 fours are, but this is 4 and this is 12. You cannot be different. So that is not possible. 3 fives are 15. Okay, 3 fives are 15. So if I take 5 here, 3 into 5, 15. See, you will also be 15. 5 and 5, you will also be 15, isn't it? So I can clearly say that T is 0 and U is 5. So these kind of questions are all hit and try. So I hope this chapter is helpful. I have covered each and every topic, and please go through the video 2 to 3 times so that you will understand all the statements. And trust me, it is a very easy chapter. It is just that you need more and more practice. So see you in the next video with the new chapter. Till then, take care and bye-bye.